Continuing with the animal class in the zoo project, you can see the videos on YouTube for everything that I've talked through. The individual files are here in the PowerPoints and will be available on course sites just for your reference. I'm going to toggle through them. We have the animal class, the zoo driver using a single animal to start with, and then we talked about reading from a data file and the steps and the process for that. This is the driver program reading in from the data file. And now we're going to talk about using something new, and it's from the Standard Template Library. The Standard Template Library contains many templates for algorithms and data structures. Of our classes, our data structure, when you create like an array of classes, they're a data structure. As an example, there's vectors, decks, lists, maps, multi-maps, and iterators are just a few of the examples in the Standard Template Library. We are going to look at one of those, and that is called vectors. A vector is like an array in that it starts indexing at 0. It's unlike an array in that it can grow and shrink. And it uses a size method, or it might be a size instance field, to determine the number of elements at any given time. The methods pushback, including a value, and popback are used to add and remove a single element. All of the methods are listed in table 16-4 in your textbook. You should look at that. These are a few of the common methods. Popback removes the last element from the vector. Pushback stores values as the last element in the vector. If it's already full, it adds it at the, basically, I think of it as the end or the bottom of the vector. At is one that you might use in your semester project if you're looking for a particular animal or you're looking for a particular item. A back refers to the last element in the vector. The other one that you might use a bit is clear, which clears all the elements of a vector, and then empty, which returns true if the vector is empty. We're going to look at a code example that implements this next. Excuse me. We're going to go to our zoo example, and I have written a program that uses a vector. If I run it real quick, it's going to have the same output as we've seen before with our zoo animals. In order to test and debug to make sure that it was actually working correctly, I temporarily went into my zoo, changed a value, reran the code just to see if it was pulling from the data file correctly. And here the weight of the Komodo dragon is now 18 instead of 180. So that verified to me that it was calling in from that data file correctly. I'll change that back to 180. But let's see what we need to do in order to use a vector. It has a special library, so we have to #include vector at the beginning of our program. We are still working with the data file. That is separate from vectors, but I still want to pull from a data file, so we're going to still keep our input file stream. We are going to replace, however, these two lines of code with the following. You use the keyword vector. The data type goes inside the less than, greater than symbols here, and then zoo vector. If I wanted to create an integer vector, I could do vector, and I would put int inside. And so, for example, I could do my scores if I was doing some grades. I could do vector. I could do a vector of doubles. It could be any data type or any structure that's in there. I'm using an animal as a type of a data structure because I created a class of animals earlier. I'm still going to use my local variables name and weight. I no longer have to index starting at 0 because the vector automatically does that. I still need to open my file. I still need to check for input file errors. And then I'm going to loop through the vector till the end of the file. All of that stays the same. I still use the while loop. But instead of reading in to an array using an index, I'm going to use the pushback method. The pushback method pushes the next item onto the vector, so to speak, and I'm pushing an animal. So I'm creating an animal right here on the fly, and we're going to use name and weight, which is the data that we got from the file. I no longer have to index it or increase the index, because a vector will do that automatically for me. And then the last kind of cool thing is that instead of using my for loop here, where I have to use less than size, which is my constant variable that I knew I had from the size of the array, I can now use this dot size method. And it is a method because it has parens on it. And then I can output the same output that I used before. So if I run this code, or you saw what the code produced before, it runs exactly the same as our array example, except it's going to produce everything using the vector. In just a moment, I'm going to clean up the code. It read in the animals, it outputted them, and using vectors. I'd still use the get name methods, and I can use the, if you notice, I'm still using the same syntax as an array. And that's one nice thing about vectors, is you can still use the bracket notation when you're getting a single vector or a vector item. And so this processes through the vector. I can go back now and I can delete out all of these lines of code that I'm not using anymore to kind of clean it up just a little bit. And so what's really nice is I don't have to know how many items are in my data file before I start. And it's unusual sometimes that you do know how many items are in the data file. And so a vector is very nice because it grows and shrinks as you need it. I did not demonstrate some of the other methods, for example, the pop back method, which will take an animal off. I could, right here, show an example of that and just do zoovector.pop back parens and run the code, and it should pull in all 4 items but then pop back one of them off, so it should only print 3 items then on my output. We will see if we have successful execution here, because pop back automatically takes off the last element in the vector if it's running correctly, and it did. Now I only have 3 items. And if I wanted to output the size of the vector, I can just output this zoovector.size, and it will output 3 instead of 4. If I outputted the size here, if I just outputted the size of the vector here, it should output, and I'm using IntelliSense here using tabs, it should output 4. And then after I do a pop back, it should output 3 if I were to run that code, just to show how it works with the size method. Zoo is 4, zoo is 3, and then it processes the 3. And so vectors are very nice, and they're very efficient for working with data, especially when you're reading in from a data file, which is going to be one of the criteria that you will have for your semester project. That will wrap up our vector example. I'll make sure to post that online as well.